Hey guys, welcome. 9.5 video. Let's get to it. We got a little vocab today, so let's get started. Alright, so essential understanding. You can use compositions of rigid motions to understand congruence. Now we've kind of gone over this already when we played our game. We're going to go ahead and go over this again, but now we're going to go into like the analog world. So let's go ahead and look at our first key concept. So please make sure you write this down. Take notes. You got to write all of it down. Two figures are congruent if and only if there's a sequence of one or more rigid motions. A rigid motion is kind of like isometry. The shape does not change size, okay? So reflections, rotations, and translations would all be examples of rigid motions. So if we can get a sequence of one or more rigid motions that maps one figure onto another. All right? So let's go ahead and take a look at a couple examples, and we'll be good to go. All right. The composition, so that means we're doing two things at once, of R. So again, for all the students that are new this semester, you're going to write down this right here and draw the picture, and when I write, you will write as well. Okay? So our question is, which angle measures have equal measure? We're going to go over that in just a second. But so we have the composition R. This little r means I'm rotating. Okay? And then this tells me by how much and about what I'm rotating it around. So I'm going to go ahead and do a rotation around point P, which is right here. And then I'm also, this composition symbol tells me I'm going to reflect across N, and here's line N. Okay? So my shape right here is rotating 90, so that's to the left. Positive 90 is actually a counterclockwise rotation. So I'm reflecting this way. So if I do that, I'm going to actually bring my letters with me. So M is going to appear over here. N is going to appear up here. O is going to be right here. And L is going to be right here. Okay? And remember, when you're rotating around something, in this case, I think, how am I going to, like that. When I rotate around something like this, essentially what's happening is we're staying equidistant to the center. So notice if I were to actually draw a line from N to P, it's going to be the same distance. So we're never getting further or closer to the center as we rotate around it. Okay? Next, let's go ahead, and I'm going to use a couple different colors here. Let's line up our angles. Angle L is going to line up with angle G, and then angle M is going to line up with angle H when we reflect it across. Again, they're going to be equidistant from the line, just like rotating we're equidistant from the point. Then we got, let's see, O is going to reflect to K, and then we got N is going to reflect to J. So basically, we end up with which angles have equal measure. Well, we can line up our letters. So angle L is going to be congruent to angle G. And again, since we did two rigid motions, we still have congruent figures. Okay, so that's key. Angle M is congruent to angle H. Yeah. Colors really help, I'm telling you. Angle N corresponds to angle J. And then angle K, or sorry, O, corresponds to angle K. Let's keep it in the same order. All right? So there we go. That's how we had to kind of rotate with it and kind of see where it was and keep it all in our minds. So this is a very visual one. We didn't have numbers to deal with, so very visual. All right, let's take a look at our next problem. And problem 2. It's a beautiful morning, da da da, ooh. All right, what are we doing? Which pairs of figures in the grid are congruent? So we were looking at these pictures. Which one are congruent? For each pair, what is the sequence of rigid motion that maps one figure to the other? Okay, so hopefully it's pretty obvious which ones are congruent. Like, I'm pretty sure this shape's congruent to this shape. We got this shape congruent to this shape. And we got basically this line congruent to that line. All right, well, let's start out with the line. I'm going to use this blue color. And what am I going to have to do to get this line to this line? Well, this looks like we're in the same orientation, right? We're orientated like this. And so hopefully all I have to do is shift it up. and maybe over some. Okay? So it looks like it's a translation, and we just have to figure out how much am I shifting it up. So let's see, we're right here. We're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 up. So I want to put positive 9. We're going to affect the y value because going up and down affects the y. And then we're going to go over 1, 2 to the left. If I'm going to the left, that's a negative rotation. Negative 2. So that should take care of the transformation for HG to PQ. Okay, so we're going to transform HG, and it's very important we say which one we're transforming, because if we do it the other way, it won't work. So that will get them to overlap. Let's take a look at our next one, the green one. So our green one, we're taking a look at this, and I'm thinking some sort of rotation here. And we can, we'll start at this one, EDF. And I think if I rotate it around 180 degrees, which would change the X and Y values, okay? So that changes the X and Y value. I had my transformation rules here. If I still have them, I don't, but I know them all in my head. So we basically want to transform these 180 degrees. So this point is negative 1, 1, and if we switch them, or negative 1, comma 1, this one become 1, negative 1, so that's going to do a 180 degree rotation. So we're going to do baby R, and then we're going to do 180 degrees rotation. Gotta get that little degree in there. Come on, come on, come on, pen. Work, work. There we go. And we're doing it about the origin, which we can call O. So that's how we would write that, 180 degree about the origin. And we're going to do this to triangle E, D, F. Okay? And last but not least, do I really want to write in this yellow? That's the question. Okay, I guess I will. I got to get this to line up. Now, if you notice, Y to X is steeper than Y to Z, or W to Z, and AJ is steeper than BC. So I'm thinking if we're over here, I'm going to want to flip it over onto the other side. So I'm thinking like a reflection maybe. Sounds good? Let's map that out real quick. I don't know. Okay? You don't have to write this part. As long as you wrote down the pictures, we're good. And our words and all that good stuff. So let's see if we can figure this out. So yellow. So let's say I reflect it over the y-axis. So let's see, that's going to end up like that. Oh yeah, that's styling, right? That's cool. And then we just have to shift it down and over 1, right? So that's a reflection and then a translation. Okay, let's do it. All right, so we want to first reflect. Ooh. Okay, so we're going to reflect, so that's big R, and we're reflecting over the y-axis. So we can say that's called the x equals 0 line, technically. And we're going to do that. And separately after that, we're going to do a transformation T. And we need to go 1 to the left, negative 1. And then we need to come down 1, 2, 3, 4, 5 units down. And we're going to do that to this shape. We're just going to call it X, W, Y, Z. And I kind of regret doing it in that yellow color, but what are you going to do at this point? So that is that. All right? So again, we've kind of doing this before. We're doing a little bit more I don't know, so to speak, analog style, but we had the first one we translated to the left and up. This the green one we rotated 180, and it was perfect. And then this one we reflected over the x equals 0 line and then shifted down and over. All right, guys, that's all for me. Peace out, Boy Scout.